Hey everybody, Mrs. Vixler, and we are back. Woohoo! Still working with trigonometric ratios, which is really exciting. And there are three, right? We learned about tangent the other day, and now we're going to learn about two other ones. Woohoo! So I want you to do a little warm up here. I want you to pause the video and solve for x. Go! All right, we're back. So hopefully you felt really good about this. You noticed that you had an angle measurement and you've got the side opposite and the side adjacent. So you knew you had to use tangent ratio. And so if we just drag this little guy down, you should have gotten that the tangent of 32 equals 8 over x. And if you did a little solve, you wound up getting that 8 divided by the tangent of 32 equals 12.8 approximately, right? So you should have gotten that x was approximately 1208. You crushed it. Sorry, 12.8. Sorry. You crushed it. Let's move on. Now, what if I gave you problems like this, the one on the left and the one on the right? What is missing here? So for the one on the left, I've got my side opposite to 15, which is amazing, that x, but I don't have anything here. I don't have adjacent. All right, now let's look over here. I've got my angle adjacent, but shoot, I don't have my opposite side. But what do I have for both of these? I have my hypotenuse. So for this one on the left, I've got my opposite side and I've got my hypotenuse. And for this one on the right, I've got my adjacent side and my hypotenuse. And those are two really important other ratios that we are going to learn about right now. So there are three trigonometric ratios. And the first one I told you about is actually the sine ratio. So the sine of an angle is equal to the side opposite over the hypotenuse. The cosine, or COS, of an angle, and in this case I'm calling it angle A, is going to be the adjacent side to the hypotenuse. And then everybody knows, snooze, that the tangent of angle A is going to be the opposite over the adjacent. So I've got here that the sine is equal to the opposite over the hypotenuse. The cosine is equal to the adjacent over the hypotenuse. And the tangent is equal to the opposite over the adjacent. So the nice little abbreviation here is SOHCAHTOA. SOHCAHTOA. This is the type of thing where if you tell your parents or you tell your like aunts and uncles or a grandparent or whatever that you are taking a geometry class, the first thing they're going to say is, oh, SOHCAHTOA. It's like the thing they remember, right? If you tell someone you're taking Latin, they're like, oh, Amoa Masamat. And like that's where their memory ends. But SOHCAHTOA is a really, really, really powerful tool. The sine, the cosine, and the tangent. And we're going to put those to work right now. All right, so, but I want to tell you first, remember how I showed you the table of trig ratios and it just had this tangent column in it? Surprise! Someone went through and they found the sine and the cosine of every single degree measurement in a right triangle, which is crazy. They did it for sine, cosine, and tangent. So we're going to be able to use our trig table for all these problems. But we also know that the calculator is amazing. So we will probably hit up the calculator more often than not. All right, so let's take a peek at this one. I want you to pause the video and all I want you to do is figure out what ratio we would be using here. Okay, we're back. So hopefully you saw I've got 15 degrees right here. I've got the opposite side and the hypotenuse, which means I'm going to be using sine. And so to set up this problem, we would simply say that the sine of angle 15 is equal to x over 32. And to solve this guy, we would do a little cross multiplication, right? So in your calculator, you would literally do 32 times the sine of 15 degrees is equal to x. And x winds up being approximately 8.28. Now, what if you didn't love the sine ratio and you said, you know what, I want to use cosine instead? Watch this. We know that this is going to be 75 degrees, right? Because I know that 15 and 75 have to add up to 90. They're complementary. So watch what happens here. Do you see how this 75 degree angle right here, this is going to be the adjacent side over the hypotenuse. So x over 32. So in this situation, what if we set up the cosine ratio? So here, the cosine of 75 degrees equals x over 32. If you cross multiply, solve, watch what you get. You still get that x equals approximately 8.28, which you should, because it is the same side of the same triangle. We have not changed anything. We're just changing the angle that we're focusing on. All right, if that didn't make sense, it's okay. Come back to this later. We're gonna move on to the next problem, and then we'll come back to that. All right, so let's try this one. All right, here we go. Just a little bit of delay. There we go. All right, so now I want you to pause the video and try and figure out this one. What ratio is it going to be? And then test it out, see if you can solve for it. Okay, we're back. So hopefully you figured out that this is going to be the cosine of 27. So the cosine of 27 degrees, because it is the adjacent side and the hypotenuse side that you have, the cosine of 27 degrees equals x over 14. And if you were going to solve here, you would cross multiply. So you get x times the cosine of 27 equals 14. Divide both sides by the cosine of 27, and you get, I'm doing this right here, live. Make sure that your calculator's in degrees, don't forget. So we wind up getting that x is approximately 15.71. And remember, it's not degrees. This would be like feet or inches or just units. All right, fab. So now, same thing. Pause the video, solve this one. All right, we're back. So hopefully you figured out. So I'm looking here at this angle. I know I've got the side opposite and the side hypotenuse, so I'm going to be using so. So we would set it up as the sine of 29 degrees equals 37 over x, and then solve. And you wind up getting that x is approximately 76.32. And remember, it is just going to be a side length. Excellent. All right. 2 more problems. Pause the video, crush it. Okay, we're back. So we are looking at this angle measurement. So I've got the side adjacent and the side hypotenuse. So I know it is the cosine of 19 degrees. So the cosine of 19 degrees, hopefully you set this up as 5.2 over y. And then you solved, and you wound up getting that y is approximately 5.5. Okay, last problem. Here we go. Ooh, this one, the degree measurement is missing. So think about what we did for back in the tangent problems. So we've got the side opposite and the side adjacent. Interesting. So if I've got the opposite and the adjacent side, what do I have there? Tangent. Amazing. Pause the video, go. All right, we're back. So hopefully you set it up as the tangent of angle y equals 7 over 30. And then in your calculator, you would do the inverse tan of 7 divided by 30, and you got that y was approximately 13.13 degrees. All right, go and tackle the homework. You got this. If you have questions, rewind this video, watch it again, or obviously send me an email. And I'll see you soon. Thanks.